What is continuity equation in semiconductors? The equation of continuity governs how injected carriers behave with time when they are injected into the semiconductor. It contains terms for the processes we have seen so far, such as generation, recombination, drift current, and mobility. For simplicity, we consider the flow of carriers in one dimension. The shown diagram is a conceptual view of the flow of electrons and holes to derive the equation of continuity. Consider a block of semiconductor material of cross-sectional area A and an infinitesimal region within the semiconductor of thickness dx at x as shown. With a potential difference V across the ends, the total number of electrons within this region at any time is the algebraic sum of the numbers of electrons flowing into the slice. The number of electrons flowing out of the slice, the number of electrons generated within the volume of the slice pi, and the number of electron hole pairs removed by recombination within the volume of the slice. So, in mathematical terms, del n divided by del t into ADX is equal to, within brackets, Jn into x into A divided by minus q minus Jn into x plus dx into A divided by minus q plus Gn minus Rn into ADX. Expanding the term of the current Jn into x plus dx in terms of a Taylor series. Jn into x plus dx is equal to Jn into x plus del Jn divided by del x into dx plus so on. And substituting in, we obtain the equation of continuity of electrons. Del n divided by del t is equal to 1 by q into del Jn divided by del x plus Gn minus Rn. A similar equation for holes can be derived with the only notable change being the negative sign for positive charge of the hole. So the equation would be del p divided by del t is equal to minus 1 by q into del jp divided by del x plus gp minus rp. When rp is formed from nn minus nno divided by Tn is the excess number of electrons in the excited state, and Tn is the recombination lifetime, typically of the order of a few picoseconds. The total current is given by the sum of the drift current and diffusion current for electrons. So, Jn is equal to q mu n Ne plus q dx into dn divided by dx. It further goes to Jp is equal to q mu p pe minus q dp into dp divided by dx. Generation of electron hole pairs is governed by the absorption process as left unchanged for the present moment. The final term allows for recombination. The continuity equation is del Ne divided by del t is equal to n mu n into del E divided by dx plus mu n E into del n divided by dx plus dn into del power 2 into n divided by del x square plus gn minus ne divided by tn. Del pe divided by del t is equal to minus p mu p into del e divided by del x minus mu p into e into del p divided by dx plus dp into del power 2 p divided by del x power 2 plus gp minus pe by dp. Valid for low current density in the classical Maxwell-Boltzmann limit.